In a uniform electric field region, the electric field lines are, you know that in a uniform electric field, the field lines are equally spaced and parallel lines. So we have a representation of uniform electric field like this, parallel and equidistant lines, arrows. A parallel plate capacitor with oil as dielectric, or dielectric constant 2, between the plates has a capacitance C. The oil is completely removed. The capacitance becomes. You know that capacitance with the air as dielectric, usually we use the notation like this. C naught is epsilon naught A by D. And if something medium is used between the plates, then C dash or C is written as C naught and C. C is with the medium. Then you should introduce a dielectric medium of dielectric constant K epsilon naught A by D. So the new capacitance will be K times C naught. Now here C itself is a capacitor with the medium. Some medium of dielectric constant 2 introduced. And here if you know that if you remove K, then that means if you divide this by K, then you will get C naught. That means if a medium of dielectric constant K is introduced between the capacitor plates, and if now its capacitance is C, and if you remove that medium between the plates, then it becomes C by K. That means with the medium as dielectric, capacitance is C. That means there is 2 inside that, there is a medium of dielectric constant 2 between the plates. When you remove the medium of dielectric constant 2 between the plates, then the new capacitance becomes C by 2. That is this option. So C itself is a capacitor with the medium of dielectric constant 2 between the plates. When you remove it, you have air capacitor, which is C by 2. Yes. Mobility of charge is given by, we know that it is the formula this one. Very simple, E tau by M. And we know that drift velocity is equal to E tau by M. And we know mobility is drift velocity per unit electric field. That means you have to divide electric field for this equation. When you divide it by electric field, you get mobility, drift velocity per unit electric field. So no electric field in this equation. It is E tau by M. Magnetic field B due to an infinitely long straight current carrying wire at a large distance r from its center, perpendicular to its axis. Okay. So if you have a infinitely long straight current carrying wire, it should be infinitely long at a distance r from its center, so that r comes outside. It will be greater than its radius. Then we know that mu naught by 2 pi I by r, magnetic field is inversely proportional to r. Yes. And whereas inside here up to the surface, it is inside, it is directly proportional to R. Okay. The material which is having low positive susceptibility value, low negative is diamagnetic. So for diamagnetic, low and negative, and for ferromagnetic, low and positive, and for this ferromagnetic, positive and high. You know this? This is so the difference between ferro, very important question. Okay. A cylindrical bar magnet is kept with its axis parallel to the axis of a circular coil as shown. So magnet is like this here. It is cylindrical bar magnet. So it is like this. And now it is rotated along its axis as shown by the arrow. That means it is rotated like this. Now the magnetic field lines of this magnet will be passing into this coil. And so the coil is having some flux. But when you rotate the magnet like this, there is no change in the flux linked with the coil. Suppose you had turned the magnet like this, say with this as axis, then you could have identified some change in magnetic flux, because north pole of the magnet will come nearer to the coil, and as this comes away and north pole of the coil will go away from the coil and the south pole will come nearer to the coil. There is a change in the magnetic flux linked with the coil when you rotate with this as the axis. But now this is turned with this as in this fashion, with this as axis, then there is no change in the magnetic flux linked with the coil. The magnetic flux remains the same. I didn't say that there is no flux linked with the coil. There is flux linked with the coil, but it doesn't change with time. So when there is no change in magnetic flux, no EMF is induced in the coil. Okay. Primary of a transformer which has more number of turns at the secondary than in the primary. So primary has less number of turns, secondary has more number of turns. This is primary. Secondary has more number of turns. The primary is connected to a DC battery. So this is connected to a DC battery. When the primary is connected to a DC battery, it will produce a fixed magnetic field. Magnetic field doesn't change with time. That is also linked to the secondary. So there is no change in magnetic flux. When there is no change in magnetic flux, induced EMF is 0. So you can't use transformer to increase or decrease the amplitude of DC. It cannot be used in DC. It should be used in AC because AC changes the current and direction also, and it changes the magnetic flux linked with the coil. That induces an EMF. So since DC is connected, there is no change in the magnetic flux, and induced EMF is 0 in the secondary. So no induced EMF in the no voltage is obtained in the secondary. Existence of electromagnetic waves were predicted by. So the combination of electric and magnetic field will produce an electromagnetic wave. That theory, electromagnetic wave theory, was given by Maxwell. Maxwell proposed the theory, and Heinrichs experimentally proved it. Heinrichs proved the existence of electromagnetic waves, and the theory was given by Maxwell. So option A. Statement 1. Focal length of a lens depends on the wavelength of light used. Yes, it is correct. Because if you take a lens, convex lens, say, incident a parallel beam of light, say if you use a colorful white light, then when parallel rays of light are incident on a convex lens, you will find that even if you can treat a lens, if you divide it into a number of pieces like this, you can treat each piece as a prism. In a prism, you know that violet color is most bent and red color is least bent. So if you take every part of this prism as every part of the lens as a prism, then the violet colors are brought to focus at a very nearer point, and red colors are brought to focus at a far away point. So the single lens will have different focal points. Red focal point will be far away since red is brought to focus or it is bent less by any lens or any prism, because every part of the lens will act like a small prism. So violet rays are brought to focus nearer. What about other colors? They will be brought to focus at different points in between violet and red. So a single lens will have different foci for different colors. And among them, focal length of red color, with respect to red color, focal length of the lens will be greater than focal length of the same lens with respect to violet color. So first sentence is correct. It depends on wavelength. More the wavelength, lesser the lesser the focal length. That is wrong. More the wavelength. For red color, more wavelength, we have more focal length. For less wavelength, violet color, we have less focal length. So second one is wrong. This is correct. This is wrong. Statement 1 is true, but statement 2 is false. C option. Option C. Condition for fourth bright fringe in the case of a Young's double slit experiment. We know in a Young's double slit experiment, the bright fringes are formed when the path reference is n lambda. The central fringe is for 0 lambda, with light coming from here and here. When they don't have any path reference, the central bright fringe is formed. Next, for next bright fringe, the path reference should be 1 lambda. Similarly, for the fourth bright fringe, it is 4 lambda. Path reference should be 4 lambda. Match the names of the scientists in column 1 with their contributions. Okay, Max Planck, he proposed quantum theory. In first year, you get Planck's quantum theory. So this should be B. I'll write it here. Albert Einstein explained the experimental observations of photoelectric effect. That is correct, C. And third one, Heinrichs discovered photoelectric effect. Yes, it is A. BCA. BCA is here. Option B. Okay. Pick out the correct statement from the following. Bohr's theory cannot explain stability of the atom. It is wrong, because Bohr's theory can explain the stability of the atom. Actually, Rutherford's theory couldn't explain the stability. According to Rutherford, the electrons, when they revolve around the nucleus, if they lose energy, then their path becomes spiral and finally fall to the nucleus. So how is that planetary model available always? So electron may fall to the nucleus. The stability of the atom is not explained, but Bohr gives that he proposes a theory where when the electron moves in a circular orbit around the nucleus, there are stationary orbit where the electrons, even if they lose energy, they go to another stationary orbit so that they do not lose energy continuously and fall to the nucleus. Stability of the atom is explained. That is wrong. Bohr's theory cannot explain spectral lines of hydrogen atom. No, it has explained the spectral lines of hydrogen atom. Bohr's theory is applicable only for hydrogen and hydrogen-like atoms. That is correct. You cannot explain it to complicated atoms where there are more number of electrons in the outer shells. Bohr's theory can explain relative intensities of frequencies emitted. No, it cannot explain. So this should be cannot. Of course, now it is correct. It cannot explain relative intensity. So this is also wrong. Bohr's theory is applicable only for hydrogen and hydrogen-like atoms. Is correct. And you are asked to find out what is the correct statement. So in these things, these types of questions, you should be very careful. Option C. Okay. Then 12th one is over. Okay, 13. Yes. The angle of scattering in alpha particle scattering experiment is 180 degree. That means if you have gold nucleus here and if you put an alpha particle, 180 degree scattering angle means it is going and coming back in the same path but in the opposite direction. This is possible when the alpha particle is very directly towards the nucleus. If this alpha particle is away from the nucleus, then it will be deflected like this. Then the deflection, angle of deflection will not be 180 degrees. Even if the alpha particle is here, then it will be deflected like this. It will not be deflected by 180 degrees. For 180 degree deflection, it should be directly towards this. Then the impact parameter is 0. The angle of scattering, scattering is 180 degrees, impact parameter is 0. It is directly heading towards. Now for this one, impact parameter is not 0. Here, impact parameter is 0. It is along the direction of the center of the gold nucleus. What is the ratio of radii of lithium to iron nucleus? Okay, R is equal to R naught a to the power 1 by 3. So you have radius of first by radius of second is a1 by a2 to the power 1 by 3. That means cube root. It is 7 by 56 cube root. And it is 1 by 8 cube root. 1 by 8 cube root is 1 by 3. It is 1:3. Diagram given below represents, yes, dot. If dot represents electrons, electrons are in the valence band. No electrons are in the conduction band. And energy gap is greater than, lesser than 3 electron volt. If energy gap is lesser than 3 electron volt, it is a semiconductor. But no electrons are in the conduction band. So the temperature should be 0 Kelvin. It is an intrinsic semiconductor at 0 Kelvin. Is like a perfect insulator. No electrons are found in the conduction band, and it's like a perfect insulator now. Even though the energy gap is less, there is no heat energy available because temperature is 0 Kelvin. No electrons are found in the conduction band. No electrons, I made that conclusion because there are no holes in the valence band. If some electrons were successful in reaching conduction band, then we could have found some holes in the valence band. So no holes are found in the valence band. So it should be intrinsic semiconductor at 0 Kelvin. How will be the intrinsic semiconductor at T greater than 0 Kelvin? Then there should be some holes here. Here should be some electrons and here should be some holes. But such things are not found here. So it should be intrinsic semiconductor exactly at 0 Kelvin. Okay. Fill in the blanks. Yeah. Magnetic susceptibility of a ferromagnetic material is inversely proportional to absolute temperature and 16. Okay. It should be here. Absolute temperature should be here. Absolute temperature. Self-induced EMF is also called back EMF. It is also called back EMF because it induces an EMF which opposes the change. Negative polarity in that Lenz's law. Then series RLC circuit dissipates maximum power when its impedance is equal to resistance. Because the current is maximum at resonance. At resonance, Z equal to R. So power is also maximum. Power versus frequency graph. At resonance, power dissipated is highest. That is when the impedance equal to resistance. Phenomenon that confirms the light waves are transverse, that is polarization. This one. So polarization. Yeah. Then energy of a photon is, it depends on the frequency because E is equal to h nu. We know that frequency. Yes. I think we have answered all the questions. Yes. Yeah. 1, 2, 3, 4, 5. Thank you.